Alright, a lot of people asked me to give some very basic introduction to Linux using Kali, and I come up with this short Linux fundamental class using Kali. So let's start. This is what we will cover today. What is Linux? Kernel versus operating system, command line, the file system, useful commands. What is Linux? The word Linux came from the combination of the words Linus Torvalds, the creator of Linux, and the word Unix. Something that was a hobby and without much expectations become something really big. Linux is normally referred as the full operating system, but it's actually just the operating system kernel, which is started by the bootloader that is started by the BIOS UEFI. The kernel is the core of the operating system. It manages the hardware, processes, users, permissions, and the file system. The kernel runs on what we call ring 0 or kernel space, and everything else that happens outside of the kernel space, we call it user space. The kernel most important role is to control the hardware components. It detects and configures then when the computer powers on, or when a device is inserted or removed, like an USB device. It also makes them available to higher level software through a simplified programming interface, so applications can take advantage of devices without having to address details such as which extension slot an option board is plugged into. The programming interface also provides an abstraction layer, allowing, for example, video conferencing software to use a webcam regardless of its maker or model. The software can use the Video for Linux interface, and the kernel will translate functions calls of the interface into actual hardware commands needed by the specific webcam in use. The kernel exports data about detected hardware through the /proc/ and the /c/ virtual file system. Applications normally access devices according to files created under the dev. Specific files represent disk drivers, for instance, the dev/sda partitions /dev/sda1, serial ports /dev/ttys0 and other components. I will now open my Kali Linux, and I'm assuming you already have it installed and running. And I want to show you that there are two types of device files, block and character. The first one is like a block of data. It has a finite size, and you can access bytes at any position in the block. The second one, the character, it behaves like a flow of characters. That's why it's called characters. You can read and write characters, but you cannot seek to a given position and change arbitrary bytes. To find out the type of a given device file, inspect the first letter in the output of ls-l. It is either B for block devices or C for character devices. As expected, disk drivers and partitions use block devices. Mouse, keyboards, and serial ports are character devices. In both cases, the programming interface includes device-specific commands that can be invoked through the I/O control system call. Alright, so let's go over some commands. The first one you want to start is the PWD, the print working directory. The PWD shows you the current location in the file system. To change the current directory, you use the CD followed by the directory you want to go. When you don't specify the target directory, you are taken to your home directory. When you use cd space dash, you go back to the former working directory, the one in use before the last cd call. The parent directory is always called ... two dots, whereas the current directory is also known as ... or one dot. The ls command allows listing the contents of a directory. If you don't provide parameters, ls operates on the current directory. You can create a new directory with the mkdir directory and remove an existing empty directory with mdir directory. The mv command allows moving and renaming files and directories. Removing a file is achieved with rm file, and copying a file is done with cp source file target file. The shell executes each command by running the first program of the given name that it finds in a directory listed in the path environment variable. Most often, these programs are in /bin /usr/bin or /usr/sbin. For example, the ls command is found in /bin/ls. The which command reports the location of a given executable. Sometimes the command is directly handled by the shell, in which case it is called a shell built-in command. cd and pwt are among those. The type command lets you query the type of each command. Note the usage of the echo command, which simply displays a string on a terminal. In this case, it is used to print the content of an environment variable, since the shell automatically substitutes variables with their values before executing the command line. As with other Linux distributions, Kali Linux is organized to be consistent with the File System Hierarchy Standard, the FHS, allowing users of other Linux distributions to easily find their way around Kali. The FHS defines the purpose of each directory. The top-level directories are described as follow. We have the bin, the basic programs, boot, Kali Linux kernel, and other files required for its early boot process, dev, the device files, etc, the configuration files, home, users' personal files, lib, basic libraries, media, mount points for removable devices like CD-ROM, USB keys, and so on, MNT, temporary mount points, opt, extra applications provided by third parties, root, administrators, root's personal files, and have the run, volatile, runtime data that does not persist across reboots, not yet included in the FHS. SBIN, system programs. SRV, data used by servers hosted on this system. TMP, temporary files. This directory is often emptied at boot. USR, applications. This directory is further subdivided into bin, sbin, lib, according to the same logic as in the root directory. Furthermore, USR/share contains architecture independent data. USR/local directory is meant to be used by the administrator for installing applications manually without overwriting files handled by the packaging system, DPKG. var, variable data handled by daemons. This includes log files, keyway's, spools, and caches. Proc and sys are specific to the Linux kernel and not part of the FHS. They are used by the kernel for exporting data to user space. The user's home directory. The contents of a user's home directory are not standardized, but there are still a few noteworthy conventions. One is that a user's home directory is often referred to by a tilde. That is useful to know because command interpreters automatically replace a tilde with the correct directory, which is stored in the home environment variable and whose user value is /home/user. Useful commands. The cat file command intended to concatenate files to the standard output device reads a file and displays its contents on the terminal. If the file is too big to fit on a screen, you can use a pager such as less or more to display it page by page. The editor command starts a text editor such as VI or Nano and allows creating, modifying, and reading text files. The simplest files can sometimes be created directly from the command interpreter thanks to the redirection command. File creates a file name, file containing the output of the given command. Command with two signs in the file is similar except that it appends the output of the command to the file rather than just overriding it. The find directory criteria command searches for files in the hierarchy under directory according to several criteria. The most commonly used criteria is the -name, file name, which allows searching for a file by name. You can also use common wildcards such as star in the file name search. The grep expression files command searches the contents of the files and extracts lines that matches the regular expression. Adding the -r option enables recursive search on all files contained in the directory. This allows you to look for a file when you only know a part of its content. Getting system information. The free command displays information on memory. Disk free, DF, reports on the available disk space on each of the disks mounted in the file system. Its -h option for human readable converts the sizes into a more legible unit, usually megabytes or gigabytes. In a similar fashion, the free command supports the -m and -g options and displays its data either in megabytes or in gigabytes, respectively. The id command displays the identity of the user running the session along with the list of groups they belong to. Since access to some files or devices may be limited to group members, checking available group membership may be useful. The uname-a command returns a single line documenting the kernel name, Linux, the host name, the kernel release, the kernel version, the machine type, an architecture string such as x86_64, and the name of the operating system, GNU/Linux. The output of this command should usually be included in bug reports as it clearly defines the kernel in use and the hardware platform you are running on. All these commands provide runtime information, but often you need to consult logs to understand what happened on your computer. In particular, the kernel emits messages that is stored in a ring buffer whenever something interesting happens, such as a new USB device being inserted, a failing hard disk operation, or initial hardware detection on boot. You can retrieve the kernel logs with the dmesg command, the dmask command. Discovering hardware. The kernel exports many details about detected hardware through the proc and sys virtual file systems. Several tools summarizes those details. Among them, the LSPCI in the in the PCI utils package lists PCI devices. LS-USB in the USB utils package lists USB devices, and LSPCMCIA in the PCMCIA utils package lists PCMCIA cards. Those tools are very useful for identifying the exact model of a device. This identification also allows more precise searches on the web, which in turn leads to more relevant documents. These programs have a -v option that lists much more detailed but usually unnecessary information. Finally, the lsdev command in procinfo package lists communication resources used by devices. The ISHW program is a combination of the above programs and displays a long description of the hardware discovered in a hierarchical manner. You should attach its full output to any report about hardware support problems. And that's it. I hope you had enjoyed this tutorial, and thanks for watching. See you next time.